Howdy. Thought this one might be a little bit interesting. I just got this open and I was just getting ready to power it up, but I noticed some liquid damage on it. Like there's some here, here, and a little bit here. It kind of looks like there was maybe a crack in the seal and water dripped in, but it doesn't look like very much, like maybe one or two drips. And it just sat on those spots and corroded. Um, but anyway, I have this connected. I want to power it up. And if we look here on the power meter, we'll see it instantly jump up to um, 310 milliamps or thereabout. And that's not normal because right now the switch is not on. Now if I turn the switch on, it actually goes down. And that is kind of backwards of what it should be. And now I can turn the switch off and it still does not jump back up unless I, take the ground away and then connect it back up. So something definitely weird going on, and I'm gonna assume it's this corrosion that's around this chip. So let's go ahead and check that out with the microscope so we can see it a little bit better. All right, so this is the corrosion around the diode here. See if I'm in focus. Okay, so quite a bit. This might actually not be causing any trouble because everything that it's touching is actually pretty much connected anyway, except for you know what, maybe this part right here could be shorting out because this is battery voltage and this would be ground. So maybe. But I think the biggest problem is going to be right here on this chip. Now this is a power management type chip and it has quite a bit of oxidation and corrosion. Like here you can see in between the pins, it looks like rust and that's just not good. There's also some on this side. Uh, Not too crazy, but and here you can see where it looks like the liquid had dripped down. I'm not sure what the liquid was. It's pretty weird. Here we have a little more. It just needs to be cleaned up. And another thing I noticed is right here, this diode. Well, actually, I don't think this is a diode. This is some type of MOSFET, and it looks like it got really hot. And right here also, this black this black dot we see, that's probably burnt conformal coating. So this got really hot enough to burn that conformal coating. Usually this guy gets hot, but he don't look like he did. But this one was so hot that it liquefied the solder and created this solder ball here from this squeezing down. And then we have some more corrosion right here. But anyway, I'm gonna clean all this up and see what happens just from cleaning. I did check that diode already. That diode, it does work fine. But it's definitely got something going on. So I'm gonna cut this away just so we can see a little bit better. So nothing here too crazy. Just that little bit that we saw. So okay, so that part will be fine. Now I want to take this away. Okay, so there's nothing under it. Clean this away some. And now I'm just going to use some IPA and just clean everything. And then I'm going to test again after that, see what happens. Alright, so I'm gonna try powering it up again. Right now ignition is off, so we shouldn't see much. Nah, we still see the same voltage. So cleaning it did not fix it. And then we turn the switch on and same thing, everything cuts off. Okay, so now there's no voltage there. This should have 13. That's what my power supply is set at, give or take. 13, 13. So that amount of current is not coming from the ignition or anything being on. It's coming from something outside of that. So something on here is shorting and causing that drain. Well, I'm not quite sure what it is yet. And, it's not enough current to actually, warm anything up. So it's going to be very difficult to find. It might be from this. It might be from this transistor right here because I don't think that this is normal. Because right now it's off, right? It should be off, this one. And we have 13 volts on this side. And on this side we have 12, which I don't think we should. I think we should have nothing there. But the weirdest part is that when we do turn the switch on, we actually lose whatever it is that's shorting out to begin with. And here we see the gate active. Yeah, I think that this whatever this is bad. So let me take it off of there and test it. Now, if this chip is the one causing the excess current draw when the switch is off, then we should be able to see that if we hook up power with it gone, then we shouldn't have that extra current being consumed there. And then when we switch it, we probably shouldn't see any change at all. It should still just be virtually non-existent. So I'm going to use my iron to help a little bit because I don't want to heat up too much beside that transformer because I don't want to damage the transformer. That's coated wire and it can melt and then start shorting out. We don't need more problems, that's for sure. So let's check this thing. And like I said, I'm pretty sure it's a MOSFET. I think it's a N-channel MOSFET. All right, so I've got our little chip that I'm concerned about here. Now, I'm fairly certain this is a MOSFET. If we look at the part number, we see T12N10, and this number looks pretty familiar to me. I'm not 100% sure, but I think this is the current. So I think it's 12 amps it's rated for. And then this is going to be the voltage, which is 100 volts. The 10 stands for 100. But I'm going to assume without looking up a data sheet that this is gate, drain, and source, right? And we're going to test it here with our DMM. I have it set into diode mode. Okay, and I'm going to touch all 3 pins because I want to discharge this MOSFET to make sure that it is not turned on, right? First thing I want to check is I want to check from the drain to the source, okay? And this should be nothing. This should be open circuit, which it is. That is good because remember we discharged it by touching all 3 pins together, and turning it off, so it should read as off, which is open. Now, when I put my red probe to the gate, that should actually charge the gate and it should turn the MOSFET on, which means now we should have a short circuit from the drain to the source, right? And we don't. We have nothing. So from this very basic test, we can already assume that this MOSFET is bad, right? And I have a MOSFET tester. I have that little tester thing that I guess we could check as well, but I don't know where I put it. Let me see if I can find it real quick. Okay, well, I didn't find my little tester, which is fine. I have two more of the same parts right here that I had been messing with from another job, which actually had similar problems with this. Not the liquid damage, but no power. And I had been testing these. Both of these, I believe, are good. So let's check those real quick the same way that we just checked the other one and see if they are working. Now this one is a little bit bigger. This one is, well, both of these are actually T14s. T14 N10, so I'm going to assume that's 14 amps. All right, okay, let me touch all three. To discharge it, touch all three, discharge it. Okay, first thing we're going to check is drain and source. That one is off. Drain and source on this one, that one is off. Okay, now let's charge it, same as we did before. And there you see this one works perfect. Okay, and we discharge it. It's going to be closed. Okay, we're going to charge it again, just another quick demonstration. Okay, so that one is good. Let's check this other one here. Okay. Oh, I just charged it. Let me discharge it again. Okay, so first let's check and make sure it's not shorted. It is not. We're going to charge the gate again. And there we go. So this one is switching good. And we come back to this one. This was the bad one, the T12. We're going to see that it did not work. I'm going to charge and check and nothing. So let me put one of the good ones on there. Maybe that will actually fix our problem. And it's easy to know which one is the bad one because that one was 12. So I better not put that there because I need that. Let's clean up the old solder here. Okay, we could put a little flux on it. Alright, and let me grab one, make sure I didn't grab the wrong one. Nope, this is a good one. Okay, just going to use lead solder here in case I got to take it back off. Just make it easier. We're working on top of this aluminum case, so every little bit helps. Okay. Gonna put some solder here on the source and the gate pins. Alright, this should be good enough. Okay, now we're gonna hook it back up. And I currently have the power switch off, so we should not see the current jump up. It should stay pretty low. And it did. So that is improvement already. Now when I hit the switch, we should see it jump up. And I usually have my pass-through device hooked up and I see about 400 milliamps. So I think we should see about 15, 0.15, so 150, 160, something like that. I think that's too high. I don't think that's good because this is almost 300. Let me plug in my pass through, and maybe we'll try to connect. Oh, you know what? I just hooked up my pass through, and it actually didn't go up that much. So maybe I was just wrong. That's weird. Did it go down when I won't looking? Okay, so that's about normal for the pass through. And when I turn this on, oh, you know what? That's about right. That's my fault. Like I said, I usually have the pass through hooked up, so what I'm used to seeing is based on that already being connected, and this is very typical of this ECU here. So I guess 400 milliamps. Um, but let me hook up the data lines. Now we can look here. We're missing this chip. So I know that this is a 2006 model, and it will have a CAN circuit instead of the SCI circuit. So let's hook those up. Yeah, and if you have your label, it's also on the label there. But now our CAN is right here. We have negative. We have CAN positive. Okay, I'm gonna flip this back around. Okay, we'll plug this in, and we will try to connect to it now. Make sure everything is right. I think that's pretty good. Oh, sorry about the floppy camera there. Let me try to get the Autel one here. So yeah, I got a good feeling about this one right now. I think that's gonna actually fix it. Now I am going to still clean this leg up a little bit. I gotta make sure structurally they're fine, and then I'll probably recode it. I think maybe what happened is that liquid damage, whatever it was, that got in here and caused all that stuff to corrode. It put extra pressure on this MOSFET here, shorting it out maybe, or just overworking it, which caused it to heat up like that and then just burn out. And then once it burned out, it was just always off. And when you try to turn it on, I guess it just pulled too much current, maybe from the power management chip, which just shut everything down. I don't know. That was kind of weird how it kind of reversed and everything just cut off. But I don't care too much about that, as long as it's fixed now. All right, so I got the scanner on here. We want to go into Dodge, and we're going to go to manual selection 2006. We're going to go to the model Dodge Ram, and we're going to go into the engine control module and see if we can communicate with it. If we can communicate with it to see, like the ECU information, and check trouble codes and see trouble codes, because it should have some. It should have about 7 or 8, since nothing's hooked up. I think is about what the normal ones are. Then I think it's pretty safe to clean everything up. So we already got our VIN number there. I think it's pretty safe to assume that this one is fixed. I mean, I'll still go through it and test all the basic functions, but I think we are pretty solid on this one. There's a few stored codes there. I always like to check for the stored codes, because whenever it says stored, that's always something that happened before I had it hooked up on the bench, which is nice to see. So they had a problem with their immobilizer key, which this is important, because if I get it fixed, I get it tested, and I see that everything is working perfect, and I send it back, and they're saying, hey, it's cranking a little bit and it'll run for like a second and cut off, I can say, well, you know what? You had this immobilizer code stored. Maybe you having issues with your immobilizer key now. So it's just information that I can see helps the customer. Here we see the coolant temperature got too high, so maybe the truck actually overheated. Cooling fans, but that's okay. Let's erase it. Okay, I wanna check ECU information as well before I leave. Just make sure there's no funky numbers, because sometimes if the memory or the programming gets a little corrupted, you'll see some oddities in this, but this is all fine. That's all normal looking. So I think that's okay. So yeah, I'm pretty sure this one's fixed. I am going to clean it up a little bit more. I'm actually going to reapply some conformal coating to those spots that are, heavily oxidized, and then I'll, you know, run through the testing of the basic stuff. But yeah, that's pretty straightforward repair there. That's nice. I like when they turn out to be something that you find visible with your eye. We found that MOSFET based on it overheating with the little solder ball being pushed out, and that pretty much told us, hey, the problem is here. You don't need to keep looking. Check me, and that's what I done, and that's what it was. So that's great when it works out that way. But anyway, I hope you guys enjoyed, and I'll see you on the next one.